Hello, welcome back to the next video. Next video we will have the fundamental forces in nature. Actually, what is called force? Have you ever seen that? Or have you ever feel that? Yes? Yeah. Even if I am holding this chalk piece, that is also a kind of force, contact force. Even if I am slapping you, that is also a kind of force, right? And similarly, we will have, in general, we will have some different types of forces in nature we will have. So, what are they? Gravitational forces, and second one is electromagnetic forces, and third one is nuclear forces. In that nuclear forces, again we are subdivided into two categories. One is strong nuclear forces and another one is weak nuclear forces. And among we have four different forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Among the four different, which one have the more force? Gravitational, electromagnetic, strong nuclear force, or weak nuclear force? Yes, strong nuclear force is among the greatest one. And which one is smallest force? Yes, of course, gravitational force is the smallest one. Okay, and before going to start about this chapter, what is gravitational force? Is deal about only the macroscopic object. Assume that this one is this color ball is sun, right? This radiant color ball is sun, and this white color ball is earth. So the earth revolving around this sun, right? This is the force of attraction between two heavier objects that deals with gravitational force, right? Then what about electromagnetic? What is called electromagnetic? Here we have electromagnetic. Yes, electromagnetic force means it have both electrostatic as well as magnetic force. As in that this spring we will have, right? If I am elongating, yes, or stretching, again I am compressing, what will happen? Yes, it shrink, right? Yes, why it happens? Due to its elasticity. In that elasticity, what will you have? Yes, the interaction between the electrons in that springs, right? It's disturbing the neighboring atoms, right? Elongation and compression, right? So elongation and compression we will have. So that belongs to electromagnetic force. And nuclear force is happening only inside the nucleus. It can be either strong nuclear force or weak nuclear force. What is strong nuclear force? Any idea about? Yes, do you have any idea about strong nuclear force? Yes, of course. Here we have the radioactivity element which decays. Okay, when the radioactive element is decays, that time it produces heavier nuclear, right? The heavier nuclear make radioactivity, it disintegrated. That time we can able to see the strong nuclear force between them. And the last one we have nuclear force, that is weak nuclear force, that can be takes place only in the beta decay. Beta decay is mainly depends upon elementary particles, right? So what are the elementary particles? In the sense mesons, baryons and leptons, these are all elementary particles which is present in that case beta decay, right? Okay, now move on to this tabular column. Here we have the gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Gravitational force is macroscopic object, the force between the macroscopic object, and electromagnetic force is also a macroscopic object, force between the macroscopic object. And what is called strong nuclear force, that is microscopic object, the interaction between microscopic object, protons, neutrons, electrons. And weak nuclear force also microscopic object, the interaction between microscopic object. And the strength of the force, the gravitational force is least 1, right? And the strength of electromagnetic force in the order of 10 power 36, and the strength of strong nuclear force is 10 power 38. That is why I said among the greatest is nuclear strong force, and nuclear weak force is 10 power 25, right? So when compare, electromagnetic force is much greater than nuclear weak force but less than nuclear strong force, but which is greater than gravitational force. How you can say that this electromagnetic force is greater than gravitational force? Yes, suppose if you take any bar magnet, okay, and there is a piece of iron which is laid on the floor, right? We are going to brought up that bar magnet nearby that iron needle. What will happen? Yes, get attracted and get lifted, right? So against the gravity is pulling up due to electromagnetic force. That's why it's much greater than gravitational force. The electromagnetic force is greater than gravitational force. And okay, and the force of mutual attraction between the heavier masses. The force of attraction between the heavier masses, that is equal to F is equal to G m1 m2 divided by r square. This is universal law of gravitation, right? And the electrostatic and magnetic forces involved in electromagnetic. So F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square, that is called Coulomb's law, right? Electrostatic Coulomb's law. And strong attractive force which binds the protons and neutrons, that is called strong nuclear force. As you know well, in neutrons we will in nucleons we will have the is connected with the protons and neutrons. Yes, the binding between, assume that this small ball is neutron, right? And sorry, this one is proton and this one is neutron, right? So it get attracted, right? It get attracted due to binding force, attraction between these two forces, that belongs to strong nuclear force here, okay? And the weaker force, the force that appears between elementary particles. I said elementary particles, what are they in the sense? Baryons, leptons, mesons, these are all elementary particles which is present in that nuclear process. And a very good example for weak nuclear forces is beta decay, and for a very good example for strong nuclear forces, radioactivity in heavier nuclei, uranium 92, 92 to 32, that is under in radioactivity, that will use under the strong nuclear force. And when a spring is compressed or elongated, that is due to the elasticity of that material which is disturbing the neighboring atoms, right? And for gravitation, the motion of the planets around the sun, right? Similarly, we can make a number of tabular columns and comparing all those properties. Yeah, the continuation with again we will have some more comparison between the forces. And the gravitational force and electromagnetic force both are obeying inverse square law. So what is inverse square law? As we saw that the universal law of gravitation, right? F is equal to G into m1 m2 divided by r square. And here we are saying the electrostatic force F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. That is called inverse square law. So that will obey inverse square law, and there is no law as for nuclear forces. And the second point, these gravitational force and electromagnetic forces are long range force. See, the attraction between the sun and earth is a long range, right? Yes. And similarly, the electromagnetic forces also a long range, electromagnetic radiations, right? That also belongs to this type of category, that is all long range, right? Yes. Okay. And this nuclear forces, both strong as well as weak nuclear forces, both are short range force, because the atoms are in the size of femto level, right? 10 power minus 15 meter. So the force range can be only in the short range, both strong as well as weak nuclear forces. And gravitational force is a central force. What is called central force? Yes, as I said, for understanding for you, again I am taking two heavier object. Okay, this is earth, this is sun, right? Heavier object. So the earth is revolving around the sun, right? Yes. What about the force? Yes, the force, this earth will also give some force to sun, and as well as the sun will also exert some force to the earth. And there is a line, imagine that, yes, like that, yes. The force acting between them as in the line, that is called, we are saying that central forces. Yes. Yes, can you able to understand what I am saying, central forces? Yes, can you? So what is central forces? In the sense, the force acts along the line joining the centers of the two bodies. These are the two bodies, right? Sun and earth. We are connecting in a straight line. Yes, the line, in that line the force will be acted, that is called central force. And in both gravitational force and electromagnetic force, both are central force. But in the case of nuclear forces, it is not central forces, that is not acting on the line. So that's why we are saying that non-central forces, both nuclear forces are. And conservative force, what is called conservative force? Okay, before that, if you are doing some work, okay, if you are doing some work, so if that work is independent of that force, if you are choosing gravitational or electromagnetic or nuclear, the path should be independent. That's why we are called as conservative force. So note down the definition: the conservative force, the work done moving a body against a gravitational force, is path independent. The path is always independent for this case, gravitational as well as electromagnetic force. But strong and weak nuclear forces both are non-conservative force. And this gravitational force, how it is caused? It is exchange of gravitons. Graviton means heavier object, mass object. And electromagnetic is the exchange of photons, light, yes, between the charged particle, two charged particles. And strong exchange of pi mesons, exchange of pi mesons, right? And these mesons also one of the elementary particles. And this one is what is called bosons. Bosons also a kind of elementary particles. Here you have to note down the messenger particles, okay, the messenger particles that transmit the weak force between these bosons, right? The messenger particles that transmit the weak force between the bosons, right? That is becomes weak nuclear forces. Yes, okay. And in that nuclear forces, I want to tell you something about extended to the syllabus. Neutrino is an elementary particle. With zero rest mass and zero charge. For neutrino, right? And second thing, if you are taking beta decay, right? Beta power minus, that means if you are writing beta power minus, right? Beta power minus that will give electrons and antineutrino. Beta minus decays, that will give electron and antineutrino. But beta plus is decay, that will give anti-electron and neutrino. Anti-electron means positron, and it will give neutrino, right? Okay. And elementary particles, I said we have baryons, mesons, leptons and nucleons, proton and neutrons, right? And baryons, pions, kaons are mesons, okay? So these are all some elementary particles which is present in physics part. I hope you understand well. Then we can go to next one, right?